Let's look at the baseline first. We have a standard Node.js server. And I know Node is the industry standard for a massive chunk of web backends right now.
Yeah, power is a huge portion of the web.
Right. So in this screenshot, they've set up a simple Hello Express server app on port 4000, and they hit it with a heavy 30-second load test using a benchmarking tool called Work.
Right, WRK.
Yeah. They are throwing 1,000 concurrent connections at it, essentially simulating a massive sudden spike in user traffic.
Which is a very stressful test for a basic server.
Exactly. And Node manages to handle about 2,825 requests per second with an average latency of about 107.92 milliseconds. But looking closely at the terminal output, there is a big block of red text showing 273 timeout errors. What is actually happening to the server under the hood here to cause those errors?
Well, those errors basically represent a server that is drowning. Node.js is incredibly popular, as we said, but it operates on a single-threaded event loop.
Meaning it can only do one thing at a time?
Exactly. When 1,000 connections hit it simultaneously, that single thread has to juggle every single one of those requests. The runtime is spending valuable compute cycles just figuring out which task to handle next, while also interpreting the JavaScript on the fly.
That sounds exhausting.
It is. Eventually, you get so backed up that the server just drops the connection entirely to save itself. That's a timeout error. From a user's perspective, they click a button, the web page just spins for a while and then says, "Site cannot be reached."
Man, now let's look at the next screenshot in our stack. This is the exact same 1,000 connection load test, but this time running against the compiled Chuks server on port 3000.
This is where the numbers get crazy.
They really do. Under that brutal pressure, the Chuks server just doesn't even flinch. In the first run, it hits over 22,000 requests per second with a latency of just 55 milliseconds.
Almost 10 times faster.
And then they show another optimized run, and it clocks in at a staggering 41,072 requests per second. The latency drops to 25 milliseconds. And the absolute most important metric here, 0 timeout errors. None.
It is processing nearly 15 times the traffic of the Node server, responding in a quarter of the time, and flawlessly keeping every single user connected. This is the raw power of the AOT binary speaking directly to the hardware, without any runtime middleman.
Here's where it gets really interesting. If you look at the code snippets provided for both of these servers, the Chuks syntax looks just as friendly as the Node code. They're just importing from standard HTTP. It's highly readable, but the performance difference is just night and day.